Okay, Dr. B here, and let's talk about standard entropy values. Somebody got the bright idea that if you can do enthalpy values for a chemical reaction and just have calculate them from their elemental states, products minus reactants, why can't we do the same thing with entropy? And in fact, you can. Here's a table that just gives the standard entropy values for substances. To have a look at it and think about whether it makes sense, right? Here's water in the liquid form. In the gaseous form, it has a higher value. It's more randomized. We've learned that, right? It's just getting more disorganized when you go from a liquid to a gas. Similarly, bromine, liquid to gas. Iodine in the solid state to the gaseous state. It does sublime, right? Diamond is more organized than graphite. That doesn't surprise me. But there's other values as well. Just helium gas, there's its, standard entropy value. Apparently it's more random than, well, it's not more random than water as a gas. That might be interesting. But all these should give you an idea of kind of the randomness of a system. Where's the power in it? You could do products minus reactants and talk about the change in entropy. That's pretty cool. So these values, as not surprising, higher means they're more random. They'll increase from solid to liquid to gas, getting more random. And here's just some standard things that should make sense to you. If you're freezing something, it's getting more organized, so it's more negative. Also notice that as molecular weight increases, you are getting more randomized. That's perhaps explains like the water versus the helium gas. So let's evaporate a beaker of water. Evaporating, that's going from liquid to gas. You're going to increase in the randomness. Dissolving things makes them more random. Cooling things makes them more random. No, it doesn't. Cooling things makes them less random, right? This would be like going from a liquid to a solid, for example. Cooling the gas, getting more organized, less movement, more organized. There you go. So as the entropy increases, you're getting more random, and the way it's oftentimes explained in a college textbook is you have a greater number of microstates. Note also that you can solve problems by doing products minus reactants and dealing with entropy alone. This is standard entropy values.